Hi children and viewers. In this video I am going to explain one more important feature of light, that is dispersion of light. What is mean by dispersion of light? So in this video I am going to explain about the topic only, dispersion of light. So children, this is a very important topic, that's why don't neglect. So dispersion of light means when white light is passes through the any transparent material, then that white light is splits into the number of colors. That phenomena is called dispersion of light. When white light is passes through the any transparent material, the light should be going to be splits into the number of colors. That phenomena is called dispersion of light. In our textbook, I think so, activity 3 and activity 4, these three are explains about the dispersion of light. So activity 3 and activity 4 I am going to explain those two in this video. That's why watch carefully and don't skip the video, children. And children, here I am giving one example here, dispersion of light. So here we have taken one prism. Clear? Here when here there is one source of light, it is there. From that source of light, white light is incident. White light is incident on the one of the refracted surface of the prism. Clear? Now it is refracted and that should be divided into 7 colors like this. After refraction, the light is going to be splits into colors like this: V, G, so now here we are getting different type of color lights. Light rays there here. Only here this thing is what? Source of light. From that light source, the light is emitted in color of white. White is nothing but here monochromatic. Monochromatic light. Monochromatic light means that should be having one wavelength, single wavelength of light. So when monochromatic light are nothing but white light is incident on the prism, that is going to be splits into the number of colors like with GR. With GR. So here you have to observe the pattern here. With GR. From bottom, violet, indigo, blue, green, yellow, orange, red. So white light is splits into 7 colors. That phenomena is called dispersion of light. Dispersion of light. So here, what is the reason behind the dispersion of light? You have to know. When white light is passes through the prism, that should be splits into the 7 colors. 7 color means what? Every color has its own wavelength. Every color has its own wavelength. That's why simply what you have to say, one wavelength is splits into the number of wavelengths. That phenomena is dispersion of light. So what's the reason behind the dispersion of light? So here you have to know about one concept, that is Maxwell's electromagnetic wave theory. So in this case, dispersion is not explained on the basis of particles of light. Here this is the concept belongs to the wave theory. Wave theory means the light should be spreads in all directions because of superposition of electromagnetic field vectors. At every time the field should be varies. That means simply here to understand about that, here this is I am showing now, this is the electromagnetic wave. Electromagnetic wave. So here simply this is the direction of propagation of light. So here I am showing that this is the electric field vector. This is what? Electric field vector. And there is another vector, it is there, magnetic field of vector. Magnetic field vector. Simply here the superposition of electric field vectors and magnetic field vectors, they are perpendicular to each other, perpendicular to each other. So due to that only here the light should be spreads in all directions. So in next chapter only we have electromagnetic wave concept. There I will explain very clearly. Simply here in this case the dispersion is possible because of electromagnetic waves. When the light is moving on means the electromagnetic waves are moving in all directions with same speed. Clear? In dispersion the colors what they are formed, they have same speed of light, same speed of light. So what's the reason behind that? Here why, just look here again, I am going to previous diagram. So already what I told you, 7 colors are there. V, D, G, R. So here you have to know that, first you have to understand that the reason behind the dispersion of light is wave theory concept. So anything here, why there is difference in the wavelength of the colors, and is the velocity of light is same for every color or not? You have to know about that. According to Fermat principle, the light must be choose the least time to reach the, that should be follows the least distance path and least time also. That's why every color what should be splits, the color of light should be goes in particular path. That's why they have different wavelengths. So children, simply you have to remember that the color what it is splits into the number of colors. The white light that should be splits into the number of colors. Those colors have same velocity of light for every color is same. But difference is that what's that? The wavelength is different for different colors. Wavelength is different for different colors. What's the reason for that? According to the Fermat principle, the light must be always chooses the least path of distance. Least path of that distance. That's why every color has its own wavelength. And next children, among the 7 colors, which color has most deviation and which color has most wavelength? So you have to remember that. So no need to confuse. Children, here we know that the refractive index can be written as mu is equals to C by V. Mu is equals to C by V. And here I am writing mu is equals to C by V. So here what is C? Velocity of light. And what is V? Velocity of light in the medium. And what is mu? Refractive index of prism or anything. Here I will write again C is equals to what, right? Nu by lambda. C is equals to what, right? Nu by lambda. C is equals to nu by lambda. Then substitute here mu is equals to what, right? Nu by V lambda. So here like that C is equals to nu lambda. Children, in this formula you have to know about mu and lambda. Mu and lambda. What I told you, C is constant for every color, and while the light is moving from one medium to the another medium, so when the white light is incident on the prism surface, that should be split into number of colors. Clear? That means the light is passes through the prism. That means refraction is going on. Along with the refraction, splitting of lights takes place. That is the dispersion. Refraction and dispersion both are takes simultaneously. What I am telling here, the wavelength should be different for every color, but the frequency do not change. Frequency do not change while it is moving from one way to the I mean one medium to the another medium. That means the number of light rays which are entered into the prism, that should be equal to the number of waves which are emerging from the prism. Clear? The frequency of light do not change during the dispersion process. The frequencies remains constant. Anything while refraction takes place, the frequency do not change, even though the velocities are different, but the frequency never change. The reason behind that, what it is, that the number of waves which are enter into the prism, that should be again coming out the prism. And children, you have to know about the among the 7 colors. Among the 7 colors, red color has least deviation or least refractive index. That's why here red is having least deviation. That's why it will go for long distance. That should be having more wavelength or most wavelength. Wavelength is very high for red color. Clear? For red color, you have to remember this point, children. For red color, deviation is less. So here, what I am telling here, this is the violet. Violet is bends more. Bends means nothing but here deviation. That's why here violet has more deviation, and its red color is bends very little bit. Bends very little bit. That's why when it bends a little bit, deviation is less. Deviation is less. Angle of deviation is less. When the angle of deviation is less, that will go for more distance. That means simply here I am here, for example, just imagine. So this is any obstacle, anything like prism, that should be coming like this and refracted. So it is going like this. So actually this is the path of incident, and this is the refracted ray. And if there is no deviation, that will go in this direction. Now it is what we call angle of deviation. Simply this is the path of the incident ray. If there is no deviation, that will go like this. And now this is the emergent ray or refracted ray. Here this is what we call delta, angle of deviation. Okay children, angle of deviation is least for red color. That's why it has more wavelength. And now here I am talking about now here violet color. Violet color has more angle of deviation, and less wavelength. I already explained now. Clear? Why we are talking about all these things? Why we are not talking about remaining colors? Why we are talking about the red and violet colors? Then what about remaining colors means? So why we are generally talking means here violet and red. These are the extreme colors. So in formation of rainbow also, extreme colors are what? Violet and red. Remaining colors are exist between these two colors. That's why especially we are talking about the extreme colors. Clear? So children, in 2 marks question and 1 mark question should be like this here. For which color more deviation is there? For which color more wavelength is there? So that's why you have to remember that. So children, for violet color, that should be having more angle of deviation and that will be having less wavelength. And red color, least deviation and more wavelength. That's why here what we say, while we are moving from violet to red color, what you have to say? When we are moving from violet to red, what you have to say? Wavelength is increases and angle of deviation is decreases. Clear? Wavelength is increases and angle of deviation is decreases, like that. So this is about the children dispersion of light simply. Now already 2 activities there, I am going to explain them. Up to now you have to remember 3 points only. The first thing is when the light is incident on the transparent material, that should be splits into number of colors. That phenomena what we call dispersion of light. That's the first thing. And next thing is what? When the light is moving from one medium to the another medium, there is no change in frequency of light. In previous example, when the white light is incident on the prism, that should be splits into the 7 colors. So here the number of white light rays should be equals to the number of colors number of waves what we are coming. That's why here frequency is same, but which can changes. And what you have to say, angle of deviation changes and wavelength also changes. Wavelength is more for red color and wavelength is less for violet color, and angle of deviation is least for red color and more for violet color. Remaining colors lies between these two. And one more thing what is that the speed of light is same for all the colors. And what is the phenomena behind the dispersion of light? Wave theory concept. What's that? Wave theory concept. And children, now in our textbook 2 activities are given. 2 activities are given. So you have to observe very easy activities. If you can read, you can easily understand that, even though I will explain here. Okay children, this is the one white wall in our room. Clear? Before that you have to take some adjustment like this. Clear? And now this is some wooden block, wooden block or anything. Clear? So I am taking some, this is the height. We are using some anything, stool or any wooden block like that. We are taking some adjustment. On that we have to keep some prism. We have to keep some prism like this. This is the prism. Clear children? And after that here we are taking some one wooden frame. This is what? Wooden board or anything. Wooden board we are taken, and for that we have to make some hole. This is the hole we are made. Clear? Now you have to open the window or door. So this is the window in our room. Clear children? What do you observe? In activity 3 we have to do this one. Already white wall is there. If white wall is not there, any obstacle is there, simply you have to paste one white paper on the wall. For example, if in that for that wall if there is no whitewash, so we have some color is there, some pink, green or red, any colors are there, then you have to paste the one white paper. Clear? And after some distance you have to keep some prism like this at suitable height. And after that we are taking some cardboard or wooden board. For that we have to make small hole. If wooden board is there, simply you can take a thick paper sheet like your notebook cover. So and next thing here we have to make some hole. We have to make some hole in the middle of the or anything. So we are taking some cardboard, we are maintaining some here hole, and you have to arrange them, all of them in front of a window or door, because once we can open the window, the light must be falls onto the cardboard. Clear? So here we are open, the white light is coming. White light means what? Sunlight. The sunlight is coming. So here this is now sunlight. Sunlight has nothing but white light, that should be having single wavelength. This is the sunlight. So now the waves which are entered, that should be passes through the, here all I told you, the light is in the form of electromagnetic waves. These waves are entered the hole and they should becomes like a beam of light. Clear? When the light is entered through this particular hole or slit, then the light becomes like a beam, and the light should be incident on the one side of the prism, and after that what you observe, the light should be split into the number of colors. Like violet, indigo, blue, green, yellow, orange and red. So that means here we will find the concept of formation of FGR on white wall or white paper. So that means here this is the one of the best activity to know about the dispersion of light. Clear? Simply with in our home only we have to do the experiment, but we need some prism. Clear? Simple. We are taking some, this is the wall or white wall. For example, wall of the color is not white, you can paste some white paper and you have to take some wooden board or any adhesive like stool, anything. On that we have to keep some prism, and in front of that we have to keep some wooden board or cardboard, and the entire arrangement should be in front of a door or a window. We have to perform this experiment in dark room. Then only you can easily identify how many colors are forming on the white paper or simply spectrum of colors. Clear? You have to perform the experiment in dark room, but you have to open the window, and from that window the light is coming and that should be passes through the hole, and after that the light becomes as the narrow beam of light, and when it is incident on the prism, here we have to take one precaution. What's that? The light which is coming from the hole, that should be splits on the prism. Clear? After that only the light should be split into the number of wavelengths, and that should be here formed on the white paper. So the colors what we are obtained on the wall or paper should be called spectrum of colors. So the pattern of color should be like this: VGR. We will find violet down. Why? Because violet has more deviation of angle, or angle of deviation is more for violet color. And if you can observe the red color has least angle of deviation. That's why we will find out the red on the top. And the remaining colors in between here VGR, remaining colors in between violet and red. So children, there is some superposition of colors also takes place. Sometimes it is not possible to observe from here to here white color, from here to here indigo, here to here it is blue and yellow, like that. So simply you will find all colors, but sometimes it is not possible to having some clear boundaries. So this is the one of the activity for dispersion of light. So this is the, I think so it is activity 3 in our textbook. Next I am going for one more activity that should be given in our textbook, and this is, to do this we don't need any prism or nothing. Simply in our home only we will do this one. So we have to take one tumbler, metal tumbler, so that should be filled with some water. In that we have to keep some mirror. Clear? We are taking some metal tumbler like a tub. What is some tub? In our textbook diagram is very clear. So it is, we are taking some metal tumbler, in that some already filled some water is there. In that you have to keep some mirror. How the mirror will make some angle with the water surface. For example, here this is the water. In that what we are keeping? We are keeping some, this is a mirror, plain mirror. So now it will make some angle. That means we must be placed like it will make some angle, not be straight. Clear, children? So after that, here I am showing separately here now. Once the white light is falling on the water surface, here again there should be S. So simply, if you want to observe only one thing, clearly, I am drawing here only one ray. So once the light which is incident on the water, that should be going to be splits into number of colors. Number of colors here, very simple. I am showing like this here. This is the light is incident on like this. Clear? Now it is splits into number of colors. Second, same Ibjar colors. If you can keep any paper on here, you will find the number of colors are same. Again same Ibjar colors. Simply we are taking some glass tumbler. In that we have to keep some plain mirror, and in that some portion of the mirror should be inside the water, and the mirror must be making some angle with the water surface. When white light is falling on that water, now water is a transparent material. Then what you say, the light should be again incident on the mirror, again going reflected back. Those reflected rays again splits into number of colors. In prism, what we observe, the same thing will be formed in this case. If you can keep any screen like that on that place while the light is coming like this, if you can keep any screen on that screen, we will find the again 7 colors, Ibjar colors. So these are the activities to understand the dispersion of light. Children, I hope you understand dispersion of light and its examples. So we will meet in the next video with some other interesting topic. Bye, take care.